topic of statistical process control. Previously, we talked about some basic concepts related to SPC. And one of the important aspects which we covered there was the difference between the common cause and the special cause variation. Now let's move on to another important concept related to control charts, which is rational subgrouping. Now what is a subgroup? So subgroup you can consider as a snapshot of the process. Let's say you are producing number of items continuously. You just take a snapshot of the process by picking some of the items which have been produced under similar condition. That will represent the picture of the process at that particular time. This is subgroup. Let's understand this with a simple example. Let's say if you have a machine which is producing 200 items per hour. From this machine, if you just pick 3 items randomly at a specific time and you measure them, these 3 items will be the subgroup for that particular process. Now remember that these 3 items need to be picked at the same time. You don't pick these item one now and another after 15 minutes or another after 15 minutes. You just pick 3 consecutive items because that will give you the snapshot of the process, that at that particular point in the process how it was behaving. Now we have understood what is a subgroup. Now the next question will be, what is a rational subgroup? So in the process control, when we are picking 3 items from a process which is producing 200 items per hour, that is a subgroup. And what we expect from this subgroup is that the variation within this subgroup should be minimum, because this should be a snapshot of the process. So in a rational subgroup, the variation within the subgroup should be minimum so that we can identify when there is a bigger change in the process or when there is a variation between subgroups. So in summary, rational subgroup separates the common cause variation from the special cause variation, and the common cause variation will be within that subgroup and the special cause variation will be between these subgroups. Let's take an example which we took when we were talking about process capability. So this is the example which we took when we were discussing CP CPK and PP PPK. There we were talking about sigma within and sigma overall. Now here in this one, a film is being measured for the thickness and we take 25 samples or subgroups, and in each subgroup there are 3 items. So let's say in the hour number 1, we took 3 measurements and these were the 3 measurements for hour number 1. In hour number 2, we take another 3 measurements and these were the measurement and so on. And these were the 3 measurements when we took at 25 hours, after 25 hours. Now any variation which you see within these 3 points, that will be the within variation, and between variation will be, let's say, between these two. So this is within 24 and this is within 25, and this variation will be called as between these two subgroups. So if the variation within subgroup is small, as we can see here in this case, this is good because less within subgroup variation will help us in easily find if there is any between subgroup variation. Now if we just look at sample number 24 and 25, we can easily say that from 24 to 25 there has been some shift in the process. Whereas if we have too much of variation within, for example, let's say if I take this example, there is too much variation within, and for example if I take another one, here also there is too much variation within. Now these two samples are very difficult to separate out. Sample number 18 and sample number 19 sort of overlap because within variation is too much. So in summary, when we are deciding on the rational subgrouping, our focus should be on ensuring that the variation within subgroup is minimum so that we can easily identify special causes. So let's summarize what we discussed on the diagram on the previous slide. So let's start with within subgroup variation. Within subgroup variation reflects the common cause, which is also called as the inherent variation or the random variation. And this is the variation which is occurring when the product is being produced under similar condition, because these items we are picking from the same time frame. So within subgroup we are expecting minimum variation because this is under similar condition. On the other hand, if we talk about between subgroup variation represents the special causes. These are due to special causes, and this helps us in identifying if there is any sudden change in the process. So this is rational subgrouping. Now, how much size should we have? So in the example, we took 3 items in each subgroup. Now, how much or how many items we should have in subgroup? So the most common subgroup size is between 3 to 5 items. And now this is not the rule. Depending on the situation, this will change. Sometimes you might even have a single item in a subgroup, which we will be talking later on when we will talk about IMR chart or XMR chart. There we have a subgroup size of 1. And in some other cases, you might have a much bigger subgroup size of let's say 10 items and so on. But generally it's between 3 to 5, and depending on situation, this can be changed. And when it comes to process control or making control charts, what we are expecting is let's say 25 to 30 subgroups. So we pick 3 items, 4 items, 5 items, and we repeat this process for 25 to 30 times so that we have roughly 100 measurements, and that is what is used for setting up the control charts. On the topic of subgroup size, now we might have too big a subgroup size or we might have a too small a subgroup size. A smaller subgroup size has an advantage because in this we are taking sample much faster, and that way we can identify any shift or drift in the process. However, if we have a larger subgroup, in that case the long term variation also get hidden in the subgroup, because in the subgroup we want a snapshot, we want a quick shot of the process. If that shot itself is taking long time, then the long term variation also might get merged into subgroup. So for that reason, you might not want to have a too big a subgroup size. Now another thing is that at some places subgrouping might not be practical, and we already said that sometimes we might have a subgroup size of 1. So basically subgroup size of 1 means we are not having a subgroup, we are just taking sample. And we might have to do this because subgrouping is not practical. Why? Because it might be a situation where we are doing destructive testing. So in destructive testing, you might want to limit the number of samples which you take each time. You don't want to destroy 4 items, 5 items every hour. That might limit your ability to take a bigger subgroup size. You might have to stay with a single one. Or maybe the test or the measurement which you are doing on these samples might be complicated. So in that case also you might want to go with a shorter or the smaller subgroup and might end up with a single item in each subgroup. Another example could be a continuous production. So for example, let's say you are mixing some chemicals and you are making some tablets or medicines out of that. It is a continuously flowing process. So in that case, subgroups might not make sense. You just might have to take a single sample, let's say every hour or every time period. So there are situations where you might have to stick with a single item or a single sample as a part of subgroup. And for these situations, we have a control chart which is called as IMR. I stands for individual value, MR stands for the moving range. So we might use IMR chart for those situations where we are just picking a single item and our subgroup size is 1. So this completes our discussion on rational subgrouping. Now the next thing what we will be doing is we will be looking at various control charts. But before we do that, let's have a quick overview of how do we select control charts for a specific condition, and then we will be going through each of these control charts one by one.